slide it up maybe a little bit. Yeah, we got ourselves some funding.
Nice.
We are now sponsored.
Thanks, UCC.
I had to, it's funny with the camera, I was running some tests. I was supposed to record on Friday, record some stuff to upload it for you guys to see, but I couldn't get it to work. And I ended up calling tech support for the problems that I was having, and they put me on hold. Because they're like, are you sure it's charged? I'm like, yes, I'm not 5. Are you sure the lens cover's open? Yes, I'm sure the lens cover's open. I mean, like all these, and I understand, because I bet you 99% of tech support it's not plugged in. So, and then finally the guy got to a point where he couldn't help me. He's like, can I put you on hold? I'm like, yeah, put me on hold. He put me on hold, and the music kicked in. I'm like, out of hell with this. So I put him on speaker, and I went online and Googled my questions. And it took about 20 minutes, but I figured out all the questions I had. And for whatever reason, I couldn't figure it out before. And he came back on, he's like, well, we can't figure out your question. I've got the entire team working on it. I'm like, I'll tell you what, I did solve it. So why don't you start recording what I'm about to tell you. And then when somebody else calls you, you can just play my voice to him. And he's like, oh, that's a great idea. And I was like, and send me a portion of your paycheck.
Right.
It wasn't too funny. He wasn't too happy about that. But anyway, we got everything squared away. Just in case you guys are interested in purchasing one of these things, just pay attention. This is a Sony. It's a nice one. It shoots really good video. It records in a very weird file format, and it's exceptionally hard to get a PC to read it. And a Mac, they even admit in the book, is not readable. It will not read them, unless you convert the file type on board the camera. That's what the guy couldn't figure out. And eventually I figured it out on my own, but it's not at all obvious. They give you a manual in French and English. The manual in English is 10 pages long. 10, that is nothing. Half of that is explaining how to charge the battery. FYI, to charge the battery, you plug it into a USB port and leave it there. That takes 5 pages to explain, apparently. So, just so you know, there's some interesting, fun stuff. Last video camera I ever used had a large VCR tape you put into it, and you put it on your shoulder and you walked around with it. So, this was definitely a learning experience for me. Okay, let's talk. Today, we've got some homework to go over. Yes, some questions I want to get answered for sure. Absolutely. Some confusion I didn't realize that was existing. And this is going to happen with this new textbook adoption. Not quite catching things, looking for interesting problems and not realizing they may open a can of worms. We'll deal with that. We'll put your guys' minds at ease. And then also start into the next bit, which involves lollipops, as you see. So first things first, though. What questions do you guys have about this? Now, please, throw that one out, Nick, that you were talking about with the bar graph versus...
The difference between histograms and bar graphs.
Yeah.
I did not mean for this, I apologize. This was my bad. I dropped the ball. I didn't realize they used both those terms in this book. All I was after, let's find one of the ones I wanted you guys to do. I think we're in, let's just grab it. There was one you said that was giving you agita?
I remember 4 and 12.
4 and 12, and that was here, right?
Yeah.
This was 88 to 102. Okay, let's go down there to 88 or 102.
I circled 4 as well.
Okay, let's take a look at 4. I think we can put your guys' minds at ease right now. Let's see, 88, almost there. All right, here we go. 88, number 4, looks like it's 2, 3, there it is,
Yeah.
2, 13, 4. Okay, beautiful. Apologies to, had I had the camera up and running Friday, I would have video recorded a solution to this and we would have no problem. Again, my apologies. So, they've given you here 600 adult Americans asked by telephone poll, what do you think constitutes middle class income? Beautiful. Not sure answers were omitted, which sometimes happens. So here's some ranges. You got less than 20, 20 to 25, 25 to 30, okay? And 100,000 plus. What percent, let's just go through them one by one. What percent indicated not sure? And remember, they said not sure answers were omitted from the results.
6%.
How did you guys come up with 6%?
You add up the relative frequency, come up with 0.94 and subtract that from 100.
Madeline, this word you're using, relative frequency, what do you think that means?
That's how often something occurs.
Exactly, as a percentage. I used the word frequency in class quite a bit. Frequency. Exactly, like I saw 2 of these, 3 of these. All this does is it changes it into a fraction out of 100. So 2 out of 100, or 2%, said less than 20,000. 9% said between 20 and 25,000. You added them all up, they summed to 94%. That means 94% of the respondents, assuming that 100% of the respondents either said one of these dollar amounts or said not sure. I mean, there might be some other one out there that there's some third option, but let's assume that. They're not sure or in here.
Yeah, the 400,000 middle-class American.
That's exactly right.
Yeah.
That's middle class, right? It's Mitt Romney. So 94%, 6%
Yeah.
is left over. They must have been one that said not sure, right? Beautiful. We'll be cool with that?
Yeah.
Is everybody cool with relative frequency versus just plain old frequency? We have another word for relative frequency, I'm not going to use it for a while, called probability. So if we randomly select an American, who do we ask? Just adult Americans, 600 of them. If we just randomly select an adult American and ask them, we can ask what is the probability they will say a middle class income is between 25 and 30,000. And you can say it's about 19%. Or roughly what? 1 in, let's give you a quiz answer for Wednesday. 19%, or roughly 1 in, be brave! 5, right on the 1 to yes, 5! Because 1 in 5 is what percent?
20.
20%. Renee? Okay, we're getting there. So 1 in 5 is 20%. 1 in 19 is, or excuse me, 19% is almost 20%. It's almost 1 in 5. Cool?
Yeah.
Good. So far? Good. All right. What percent think that middle class is between $25,000 and $50,000? There is no class that goes from $25,000 to $50,000. So what do you have to do? Just add them up. You got 19% here, 26% here, and you've got 18% here. Add them all up, and you get
63.
I trust you. 63. I can't add anymore. So 63%. Beautiful. I was going to guess 60. Cool. So what's that? That's like 2/3 ish.
Yeah.
2/3. 2/3 are going to guess in there. And later on, we'll learn about the bell curve and how roughly 2/3 of the data in a bell curve is within a certain distance from average. We'll get into averages today. It's kind of where we're headed today. Well, so far?
Yeah.
All right. Construct a histogram of data. Should all bars have the same width based on the data? Why or why not? How should the blah, 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 blah be handled? Okay. This is, I think, where we started giving you guys agita, and I apologize. All I really wanted you to do, was to take that and make it pictorial. Have a bar less than 20,000, have a bar 20 to 25,000, have a bar 30 to 40,000, 40 to 50, 50 to 75, and so forth and so on. That's all I wanted. That's all I wanted. I know that I'm scrolling through now and seeing the entire text. Remember, this thing's 700 pages long, and to get it ready for this fall, I was basically just going through these sections and glancing through the rest to see where things synced up. There's a bit of a discussion in there about how to manually restructure them so all the widths are the same. Ignore that, please. That's what we have technology for. Technology does all that for us. Now, there is a question. So basically, the histogram, just turn that into a two-dimensional object. That's all I was looking for. So please don't, yeah. Nick, you weren't overthinking. You were doing exactly what the book was telling you to do, but it was confusing as all
And
get
that's
out.
what I did, but then you get down to E.
Don't worry, we'll get to that. We'll get to that. Actually, we won't get to that. I'm going to chop that. So, should all bars have the same width based on the data?
Yes.
Okay, so the answer could be yes or no depending on what you think. I mean, the way they gave it to me, they're not the same width. This is 5,000 wide, this is 10,000 wide, that's 10, this is 25,000 wide, right? This is 25,000 wide-ish. I think it's also kind of odd they gave us, everything's in thousands, and this is 99,999, and then it jumps from 100,000 and up.
That is weird.
It's a little strange. So how could we, let's think about this from statistical display, ease. How could we represent the width of those bars in a different way? I mean, you could make the bars the same width. I have no problem with that, Madeline. That's what I would have done too. The only problem you run by doing that, and this is something to talk about, not to be marked right or wrong on, is if somebody reads it very quickly, they may make the assumption in their mind that this is the same width as this. You see? So could we, and nobody actually does this, but that doesn't mean it shouldn't be done. Could we make a histogram where we simply make the bars wider if the ranges are wider?
Sure.
We could do that, couldn't we?
Sure.
That would actually be more mathematical. Let's do it. Let's do it. Let's mute that. Let's at least get it started so you see. I'm not saying this is the right answer. This is an answer. Get used to statistics. Get used to just the process. The process is what I'm after. Nobody's going to tell you if you're right or wrong. Come on, Tim. Nobody's going to tell you if you're right or wrong. They're going to be interested in your process and your data. Okay? So, I'm going to need you guys. Anybody have the book with them? Probably not because it's an e-book. Oh, you do? Perfect. Perfect. And this is, John.
Yeah.
Jonathan, thank you for, and your name is, what's your name? Stacy. Damn it. That's cheating. Jamie. I knew you guys before. That's cheating. John, thank you. Okay, so the lowest we had under 20,000, correct? Under 20,000. So let's just do this. Let's just do a real quick. You would use technology in reality to do this, obviously, and we're going to learn how to do that as we go through this course. But just for a ballpark here, let's make a little histogram here. Let's put down here. We're actually graphing estimates for middle class income, correct? Yes. Is that right? Right. Estimates for middle. This could also be the title of the graph if you want to. But we'll put it down here. Okay. Now, Madeline, I got no problem with you making all these bars the same width. None. None at all. None at all.
Good.
But one way, the way they asked that question, should all the bars be the same way? What if they're not? Let's make them so they're different and see if that maybe gives, well, we can do it two different ways if you want to. But I'm going to call this 0.
Yep.
And we'll call that over there. Here's where it gets tricky because this is 100,000 plus, doesn't it?
Yeah.
So what do you say? Where should we put 100,000, do you think?
Right there.
Like there-ish.
I was going to think the exact same thing. I was going to think the exact same thing because that gives us some right room to go into if we need to, huh? Yeah, good. So now we just split up the axis uniformly. Maybe by 20,000s or 5,000s or something like that. There's 50. Okay, let's go by tens, I guess. We got
That
4.
looks a little bit less than halfway. But
Is that less than halfway?
I think so.
Well, then we'll go there. Is that fair?
Yeah.
I'm sorry, I am getting it from an angle, so good, we'll go there, that's fine. So here would be 25, right? Is that about right?
That's good.
Is it good? You can be honest. And again, I've become somewhat lazy in manually graphing these things because technology does it for me like that. Which is part of what you, like I said, part of what you learn in this class. All right, 75,000. And so forth and so on. We can subdivide it more if you want to. We can go 12 and a half, 37 and a half if you want to. We got ourselves a rough estimate for where those things are. Let's ignore the less than 20s and the 100,000 pluses for right now and just draw out the rest of them. This is relative frequency, right? Relative frequency.
Or you could also call it probability. Is that what you're saying?
Or call it probability, you can call it percentage, you can call it any of those things. Let's use just the word percent for right now. Just because I think percent probably makes more sense in your mind than probability at this moment in time. I did press record on that thing, didn't I? Is record? Thank you. And that's Roxy.
Danielle.
Danielle. Danny? Was
Yeah.
it Danny? I knew it was an E. Where's Roxy? She's in here too. Thank you. I'll learn your names by week 10. Andrea?
Yeah.
Ah! Whew. Okay, let's stop while I'm ahead. Where should we put 100%?
At the top?
You can. And this is, you can put 100% up there because you can't go above 100%. Right? You can't go above 100. You can go 0.5 down here, 0.25, 0.75, and so forth. You might want to break these up more. It gets a little ridiculous after a point breaking up anymore because the marker starts filling the space up. That's not perfect, but it's arguable. Okay, the next region, John, the next region past 20 was what, 22?
20 to 25.
20 to 25, so here's 25,000. I'd have to split this up into how many regions to find 20?
5.
I'd have to break it up into 5 regions, right? So my first region would be from here to there-ish. That's probably a little too big. How's that look? About a fifth? Ish. And that percentage is?
20. No, it's 20.
0.09.
0.09, beautiful. So here's 25%. I gotta come up about 40% of the way. About 40% of the way. There's the first. And if you want, and this is complete, I do this on my histogram / bar graph / whatever you want to call it. I'll put the percentage above the bar. I always do, Tiffany. I think Excel defaults to that. If it doesn't, you can set it up very easily. I like putting the percentage on top of them. It also negates the need for this axis over here if you do it that way, but I like having that just as a standard math thing anyway.
And they're all going to be touching.
That's okay. I'm okay with that
So
too.
the percentage is a good thing to have.
Oh, I see what you're saying,
So it
John.
doesn't look like it.
So it's instead of just a set of stairs,
Yeah.
it's a reference for this. Like more information generally can be a good thing unless it's bad information, in which case you get the internet. Okay, what's the next one? 25 to
30.
30. So we're going to be about the same width, aren't we? Right? Now, one thing, there might be a problem we're creating as we create this. We'll fix it momentarily. And what's the percentage on that one, John?
0.19.
So that's up to about here, I guess, yes? Okay. And on Excel, this would all be very nicely colored in, and it would be correctly scaled. Okay, next one, I think is where we start jumping to
30 to 40.
30 to 40. So now we're going to be twice as wide, aren't we? And that percentage is?
0.26.
0.26, up here. I guess it was a little superfluous going this high on the, yes. Neil saying yes, I would have told you that. If you give me 3.5 seconds to. And then 40 to 50?
Yep.
40 to 50 goes?
0.18.
0.18. So here's 12 and a half. We're going to go to here. There's 0.19, a little bit below that. Like it, like it. 50 to
75.
now we're going to gap that whole thing. We're going to gap that whole thing, and we're going to talk. What percent is that?
0.17.
Okay, we're starting to drop a little bit here.
That one's actually 0.18.
It is. I just, as soon as you were saying that, I realized I wrote the wrong number down. That's 0.17. Love it. 75 to
99,999.
which takes us all the way through that last bit, doesn't it? And that was very, very small, yes?
0.02.
2%, which is, yeah. And then, we haven't dealt with the first and last bars yet. Who said below 20,000? What percent said below 20,000?
0.02.
2%, just like that first one. Anybody opposed to just doing this?
No.
Because technically speaking, they said 20,000 or less, or I guess less than 20,000. So I mean, it's okay to do that because they might have said 0. They probably didn't. They might have said 0. Totally fine. Okay, how do we deal with the 100,000 plus, which was 1%, correct? That was 1%. How do we deal with that? What do you think? I'm not saying there's a right answer for this. I'm saying, how do you deal with it?
Can we drop it?
Can we drop it? We could. We could drop it. We could drop it. It would change the average if we were interested in calculating the average. Matt, that was your comment to drop it? Yeah, it would change the average if we were interested in calculating the average. Yeah, it would change the average. What's else? Dropping it is definitely throwing the data point away and calling it an outlier. You might, and we'll deal with this in this class, also throw out the low end if you throw out the high end. Because you might notice that the shape is going up and then coming back down again. Mm-hmm. So you've got the majority talking about the 60, I think we calculate 63% are in here. So you might be able to throw away the highs and lows and say those are ridiculous estimates.
It tells you to have a left endpoint but not a right endpoint.
Oh, it tells you. Okay. Well, that was my next guess, was to do this and see if you guys can live with this. Do one of those where it just indicates that it's down, or break the axis itself with that, so you can see that the axis keeps going, but you don't know where it stops, because who knows what they guessed. I mean, you can get ridiculous and find the most wealthy person in America and use them as the high end, but there's no difference really between that or dropping it or just having that little breaking there. So that's one way of doing it. Make the bars represent the widths of the. That would confuse people, I guarantee.
Yeah, it doesn't look visually appealing.
Because you're not used to it. Exactly, because we are not used to seeing histograms that have variable width bars. You've never seen them in the news before. And when you do, you think something's wrong. Renee, what's on your mind? What's on your mind?
Well, I was just going to say it looks confusing because it looks like the majority of people believe that 50 to 75,000 are.
Because you're equating this distance with percentage. That's why it could potentially be dangerous, because people will associate the x and the y as y and x. And I don't know how to adjust that other than making more and more people take statistics classes. Honestly, that's not a wiseacre comment. If you're looking this way, if your eyes are going left to right, what's the unit on your axis? If your eyes are moving left to right, what is the unit on the left to right axis? What unit of measurement is being used on the horizontal axis?
Money.
Money, dollars, not numbers, not percentages, dollars. So when you're looking left to right, you're saying, oh, okay, between 75,000 and 100,000. That doesn't tell you anything. That just tells you between 75,000 and 100,000. The data point that tells you how many people are saying it is the vertical one. So the reason I don't like this is the same reason that you guys bring up. It can be potentially confusing to folks. I agree with that wholeheartedly. The reason I love it is because it implies the variance in the estimates as you get further this way. That's why I like it. Because these are getting wider as we move to the right, which means those people on the top are guessing more and more varied responses, whereas down here they're kind of guessing very. This is the lone exception. But these are very tight and it's getting wider and wider and pretty soon ridiculously unusually wide. So So you could choose to just ignore them. That's possible. That's possible. Throw out the high, throw out the low, as Madeline said. I love that idea. But that's what I was looking for, that kind of discussion, really, Nick.
Okay.
And as far as the bar graph, apologies, throw it out. Throw the bar graph out. I didn't even see that in there, honestly.
And then also, because like on this one it just says, should the margins be wide, why or why not? But then in the problem, the next one, the age groups, it says they will not be the same.
They will. Here's the deal, friends. What I was after, and I think you're reading into it beautifully, Nick, and I appreciate that, but I didn't want to torture you or anybody else, or Patrick, or anybody else that agonized over this instead of going out and enjoying the beautiful weekend that we had. I really just wanted you, whenever you had one of those, let me find another one. Not that.
12 is one.
There, right there. Number 12. All I wanted you to do was to graph that. That's all. X-axis, Y-axis. That's all I was after. And I will make a note of that from now on. I appreciate you guys are somewhat my guinea pigs. First time using this text, first time kind of feeling things out. You can't read my mind, which is probably a good thing for all of your sakes. So I just...
Either way is correct.
Either way, what you say.
Like,
yes, yes.
Can,
to say that showing data is in an incorrect way means that there's a right way. There is no right way. If you make the bars the same width, if you make them variable widths, they both get the job. You get the job done. As long as it's correct, as long as you're correctly representing it, I'm a happy guy. Is that fair? This is going to take some getting used to because I have to unlearn you guys in your algebra.
There's right and wrong, is what
But there isn't.
Yeah, that's right.
There's non-misleading is what we're after. We're not really at. Say that again.
Undefined.
Yeah, really. I mean, statistics is a human-created subject. Renee, go.
Could you, with the histogram, that there's a small middle class?
Well, remember what we're graphing here. This is great. This is a fantastic statistical question. Let me mute the screen and come back to it. This is a fantastic question. I wasn't going to go here with it, but I'm glad you did. Can you infer from this that there is a small middle class? Would you expound on that? When you say small middle class, you mean a very low populated middle class? Like there's a high, or maybe there's a tiny upper class, a ridiculously large lower class?
Yeah, like I guess people think there's a small middle.
Okay, so maybe not so much that there is or isn't a small middle class, but the assumption or the perception of a middle class is small. What do you think? Answer that question. Does this give us that indication that there is a small? When you say small, you're talking about income-wise, small. So I'm not trying to put words in your mouth. I'm trying to make sure I define, well-defined versus undefined, well-defined. There's a small margin between which the middle class earns. Is that what you're getting at, Renee? So, what do you think? Does this imply that there is a small region of money between which? Madeline, you shake your head no. Tell me why.
Because if you're looking at the distribution, you've got somewhere between 25,000 and 75,000 for the majority. That's a huge swing.
That is, isn't it?
Yeah.
And what percentage is that? That's 11, 12, 13, 14, 16. That's 80% of it, isn't it? That's 80% of the respondents. 4 in 5 of the respondents claims between $25,000 and $75,000. So there's an argument for no. I'm not saying there's a right answer. There's an argument for no. Go, John.
I kind of say no as well because the sample size was only 600 people.
Okay. I like that very much. You have to accept a pretty large margin with 600 people. 600 people is actually not bad. It seems like it is when there's adult Americans, correct? I believe there's 150 million of us, right? So 600 seems ridiculous because it's I don't care so much that it's only 600 as long as the 600 were drawn mostly randomly. I'm okay with that. It is a little small. I like to see 1,000. And John's going to say that's not much better. Actually, it is. But I like your point. I like your point. Assuming it was done representatively, though, I'm less concerned. Good. Madeline, please.
Well, I mean, this might not have anything to do with this graph at all, but if you poll somebody in San Francisco versus somebody in Mississippi, like, there's going to be a huge disparity in what actually is middle class.
Yes, and hopefully, I got 2 things to say about that. I love what you bring up. Hopefully, was the word random in that problem?
No.
I remember the call was in the problem. No random. Okay, let's hope it was random digit dialing. Let's hope. Number 2, I love the fact cost of living. Large urban areas versus small rural areas. That might be this indication right here. Might be the coastal large urban centers. This might be the little tiny mom pop back. I mean, who knows? Who knows where it was drawn from? I'm assuming it was done randomly, and that could explain the variation. That's good. So Renee, I'm not sure how to answer your question. I think 25 to 75 is pretty wide too, But it would also be nice to have them also define what lower and upper class would be and compare it and see if we get maybe if we actually do get 3 humps. And the humps would actually show us where like the average is. Where's our average here? If you had to say, give me a dollar amount to the nearest, say, $5,000 that a middle class person earns, to the nearest $5,000, what would you say based on this graph? And there's a bunch of different numbers you could give.
Probably about 35 to 37.
35 to 37, so we'll go with 35,000 or 40,000, somewhere in here. Somewhere in here. What do you guys? Anybody saying lower than that? Based on this? Higher than that? Based on this? Just about that? It's right around 40,000 bucks. There's the. Matt, how did you get that? Just out of curiosity.
Well, so the biggest bubble is between 30 and 40,000, but it's heavily weighted in the upper side between the 40 and the 75. So you got to draw it up from the 30, but not over 40, I would think.
That word weight, that just made me so happy to hear that.
Oh.
The idea of a weighted average, is so huge. It's so huge. That's kind of where stretching the bars out helps us because it lets us see the data stretched, but the weights, those weights up top are definitely more important.
Pulling it up. Yeah.
Yes, because that 100,000 is pulling whatever this was. They asked 600 people, right? So 6 people of the 600 said 100,000 or more, going by the percentages of the sample. Correct? Does that make sense? I mentioned margin of error before. You have to apply that to this estimate, John. So if there was a 4% or 5% margin of error, you'd apply that to the 1%, to the 2%, to the 17, and so forth and so on. That gets comically high when 5% or 1 in 20 of your respondents are saying 100,000 or more, and it starts to get a little arguably false.
But even if you cut that off, if you look at this is where the distribution I think matters because you've got 25 to 30, which is 0.19, but you've got 50 to 75, which is 0.17. So you're talking about a lot more money with that 0.17 than you are about the 0.19.
A lot more perceptions of money and a lot more variance in the estimates. Here's the problem I have with trying to cut this into different widths. As soon as you start doing that, suppose you want this to be every $5,000 instead of every 10,000. Okay, so we're here. We're at 5,000 here. We're at 5,000 here. We're not at 5,000 here. So essentially what you'd have to do is cut that in half and then take that and cut it in half. Make it 13 and 13 and spread it out that way. But who says that's what actually happened in the data? You're making an assumption that actually happened. You can't do that. You're not allowed to do that. I mean, you can, let me take that back. You can do that. I wouldn't do that.
That's not ethical.
I don't think it's ethical. I mean, it might be, sometimes there's a difference between ethical, knowing ethically wrong, and doing what you think is right. And you're so used to mathematics, you're like, well, hell yeah, if it goes 2 here and 26 here, if I cut it in half, it's 2 rectangles, both 13 high. That's assuming something about the data you don't know, the underlying nature of the data. So if you want 5,000 bars, go back and break down the original data that way. John, go ahead.
They should have just fixed it before they submitted the survey.
Perhaps, but honestly, they don't. And I say they, news media will often just group it like this. I don't know why. I've seen CNN poll after CNN poll where the ages are in the left column. One of my favorite is the Tea Partiers. There was a theory years ago that Tea Partiers are older than non-Tea Partiers. It's complete and total garbage because I have the data from CNN's own poll. But the ages go from 14 to 24, then 25 to 27, 28 to 36. They're all like randomly all over the board. And it brings up this question again, like why are they like that? So we'll see how to deal with all that. There's ways you can do computation with data in this way. There are some assumptions you have to make, and I think they're okay to make, and you'll see why momentarily. When I say momentarily, maybe half an hour. We'll get to it. Fair? So Nick, rest easy. Okay. Patrick, rest easy. I'll go in and strike all the stuff about bar graphs off of there. I didn't want you to overthink it and do any more than this. This is all I was after. So apologies for making you guys suffer through that. Anything else in there give you guys grief? Let me fire this up again. Anything else? Any of the E problems? Go ahead. Go ahead, John.
Page 40.
Page 40, let's find
Number,
out.
I think it was 17.
So if it's 86, it's 96, so I bet you I have to go to 50. Hot damn. So go ahead.
16.
That's math right there, you see that? Let's see what's that here. 60.
16.
16, that's this guy up here. 19 immigrants to the U.S. for how many years they had lived in the U.S., this one right here?
Yeah, I just had a question on it because the frequency only adds to 17.
this frequency, and there are actually 19 of them?
Yeah.
Well, there's a problem now, isn't it?
No, but it says that. It says fix the errors.
Fix the
If you
errors.
hit A, it's fix the errors
Uh-huh.
on the table
So
first.
Yes, well, let's figure it out.
Right, but in the question up top, it says 19 immigrants.
Yeah.
But
So-
what Madeline is saying, if you
Yeah.
look right here,
But you have to look at the bottom of page 39,
It
and
says
it
fix
gives
the
you all the
errors in the
data,
table.
and you gotta double check that against this, and then if you do, you realize that the two bottom ones are wrong.
Yeah, so fix
so that,
these.
all we gotta do is, I'm gonna let you guys explain, you do a good job.
Okay, okay.
So, what I'm hearing from Madeline and Danielle, I think, is that the 15 and 20 are wrong.
Yeah.
They
so
should be
they're-
2
exact-
each.
Uh-huh.
They should be 2 each. So the errors, John, put
Okay.
your mind at ease.
So you wouldn't just cut the graph back to 17 people?
No. Here's your raw data. Raw data is king or queen.
Okay.
Raw data is everything. That's all you've got. You have no questions when you have raw data because everything's there. The problem is when you try to summarize it out of this table, it becomes incorrect because you've left 2 raw data points off.
Okay.
And who knows why? Probably just careless note taking. So you would change that to a 2, yes?
Yep.
That
Yeah.
to a 2, yes? These would both become 2/19ths then, yes? And I think I told you to ignore this column, yes? Ignore this one over here.
Oh, I don't know if you did.
Oh, that's
It's
okay.
all, it's all right except for the
Except
second
for
to the last
the one
one.
above it, right, 8421. You can ignore that one. You can ignore the cumulative relative frequency column for now. We'll get into that later when it makes more sense. But that's all it was, John. Just fix
Okay.
fix the errors. Is that cool? Yeah? Believable? Any other questions about that? Madeline, go ahead.
On page 91.
Oh, 91.
Number 12.
101, I think.
um,
Okay, so we have a formula. Whenever everybody wants a page in our online textbook,
It's 10 pages.
we add 10 more pages to it, and that gets us where I have to be. Hells yeah. All right, go ahead, my friend.
Okay, so I was I was good. I got through B, and I figured that was 49.7.
Oh.
But then which plot most resembles the information
Oh.
above? I don't know.
Crap! I didn't say don't do C.
I picked the middle one.
Yeah.
You weren't
That's what
supposed
you
to do
picked?
C.
Yeah.
Okay.
See, we didn't talk about box plots yet because they're a See,
The
I
middle
apologize. You guys are my guinea pigs. I apologize for that.
It went lower, so I picked the middle.
No, but we'll come back to that question. I'll have you that question later.
Okay.
When we actually talk about relative position and box plots and what you're looking at there. But we didn't talk about it. Okay. No bar graphs.
Yeah.
Cut.
Still not though.
Cut. Not gut. You know. Cut. Box. Plot. Box. Plots. Sorry, Madeline. That was not intended for you guys to do.
That's
My
okay.
apologies.
Okay.
Yeah.
Cool.
Never talked about box plots yet. Therefore, you don't know what the hell you're looking at yet. You might be able to figure it out. But at the same time, I don't want you to. You were hinting at it back here. I'll go back and re-PDF this whole sheet and clean it up for you guys.
Sweet.
Thank you, and I apologize. What else? What else gives you grief? Besides the whole thing. Let's be honest.
Actually, I was working on this last night and I was like, oh no, it's midnight, I should go to sleep. And then I swear I worked on like just a little bit more and it was 1:30 in the morning and I was like, whoa, I'm all caught up in this, wow.
It's interesting.
Yeah.
It's new. It's different.
Yeah.
It's one of those things. Don't lose sleep over too much, though.
No,
You
I
start
don't
acting
intend
like
to,
this.
but I just couldn't believe that I was so into it that I lost an hour and a half.
It is so different than what I told you before. There's no math in here. Well, there's very little math in here. X plus 10 to get the page number on a PDF document or whatever we did earlier. Very little math. I'm much more interested in discussions that arise from questions like Renee's, where what does that graph, that's not the statistics question, what does that graph tell us or what is it implying? We don't know. It's data. It's not saying anything. It's not telling us where the it's telling us what 600 people thought. But what can we glean from that? What can we glean? There's no right or wrong answer. There's just back and forth ideas that we pop out. And I love that because that's what I asked you guys to submit to me. You have to unlearn the x equals 3 mentality of algebra classes. You have to unlearn that because x doesn't equal 3. It's 3 plus or minus something. And then that's part of what this class is also understanding that. John, go ahead.
On page 102, I just want to let you know that it's asking us to enter some stuff into a random number generator.
Oh, is it?
Yeah.
Pain in the ass. Hang on. 112 or 102 you said, right?
It's question 31.
31.
Page
Random number
102.
generator, pick 8 states. Right there, I see it. Letter B.
Yeah.
So we need to, I need to skip that part B. Or, better yet, creative generator for you guys to use.
That'd be cool. I just did
Or
it.
just pick random ones.
I just did it with a highlighter. I closed my eyes
That's
and it was
cool.
just like that.
That's cool, but I need to at least get the guidance on how to do that, don't I? Please, Tiffany?
You don't have 32.
No, it's 31. It's actually 31. 32 is the one under it. 32 is down here. This is 31 up here.
Got you.
Yeah. But what I'll do is, this is good for me to hear, I'll simply just create a random number generator for you to use that you can link to offline, or just tell you how to do like a close your eyes and drop 8 pennies on the paper and see where they land. So random number generator on number 31. I will fix that. Thank you. Thank you very much. We'll take care of that. Thank you, John, for bringing that up. Anything else give you guys grief? Please. Let me get it again.
Jared.
Jared, thank you. Go ahead.
I don't remember which one it was, but there was one about math students.
Math students?
And it was about the population and the sample.
Oh, yeah, that's, that was
Oh,
like,
this is going to be tricky. I'm going to have to go back to that. Yeah, and it was students, you said?
Yeah.
that was.
It was number 19.
Oh, thank you. You guys have it. Thank you. So it
No,
looks like,
18, right?
18, yeah.
but it's on page 36
18
to
or 19,
42.
one of those.
No, 96.
96. Oh, in the wrong place. Thank you. So that's 106. 18, this one right here?
Yeah.
A survey of enrollment of 35 community colleges. That guy right there?
Yeah.
Beautiful. Organize the data into a chart. Boom, here we go. This is beautiful. We have to make our thing from scratch. No problem. We can handle this. 5 intervals of equal width. Label the 2 columns enrollment and frequency. Why enrollment? Oh, because first they want an actual raw count, and then they want a frequency, percentage of that. I'm assuming. Or enrollment being, yeah, we got this. Construct a histogram. If you were to build a new community college, we'll come to that. And I probably didn't have you do D, E, and
You just had us do A and B.
Right. E, D, E, and F. We're going to be learning about it next week together. Okay, so this is a little bit different than the other ones, and I intended this to be a little different. How are we going to do this? What do you think?
Well, you have to divide it. It says by 5.
We want
intervals.
5, right? So we want an enrollment. We want an enrollment, and we want a frequency. And there have to be 5 of them here. So the question becomes, how wide should they be? Or what should they start with? Danielle, help me.
You need to find the lowest number there and the highest. And
I
find
think
the
that makes sense, doesn't it?
Minimum, maximum.
Let's find the min, let's find the max. That kind of makes sense. So let's find them. I see a 2044.
There's 1550.
So 1550. 1263 over there.
Yeah.
I think that's it, right?
Yeah.
Okay, keep that in mind. So we got a min of 1263. Can you guys look in that camera? If I'm right over here, is that visible in there?
No.
It's not. Okay, I'll turn it. You guys.
Right there. Yeah.
As I'm running. I'll just do that. So the min is 1263. How about the max?
Is 28.
28,165.
5.
Beautiful. I'm going to trust you.
Yeah, I hope so.
If not, we'll put eyes on it. Put eyes on it. Glad they didn't organize it in order for us. Because raw data will come to you like this. Here it goes. Here it
Is
goes.
there an easier way like plug it in Excel or something?
Well, if we had this in a CSV style, if we could make this a CSV and drop it into Excel and then separate it out individually, yes.
Okay.
But actually, it's quicker to do it like this because of the formatted. Yeah. The question that Nick asked is it an easier way to do this in Excel? There could very well be, where you highlight the whole thing, then drop it into Excel, and then you paste it as data text to columns, and pick the symbol that separates them, like a semicolon or something like that. Patrick?
The small computer screen can't like.
Well, possible. The other thing too is, depending on the formatting of this PDF, it might let you do it.
Gmail.
Or use Gmail. Use the
Import it to
Google
Gmail,
spreadsheet.
and then you can export it as a certain file.
Oh, no, sure. The question is, can I actually get this to become 35 different numbers? That's once I've got it into a spreadsheet, I'm golden. The question is, can I get that into a spreadsheet? I have to type every single one. I think we're okay doing it like this. All right. Now, what do you think? With a min of 1263 and a max of 28, what do you think? Should we make 1260? Here's a question for you without a correct answer. Should I make 1263 be the beginning of the lowest bar? And you're telling me, tell me your name.
Sherry.
Sherry's saying no, and I'm tempted to agree. Why?
0.
Because or 0. We can go with 0 as a low. I wouldn't use 1263. That seems a little bit obtruse, doesn't it? I mean, down to 1263. Sherry says let's go with 0 as a low bound. I can live with that. What should we go with a high bound?
30,000.
How about 30,000? Why do we like 0 to 30,000?
Because
Why is it pretty? Oh, okay, I like that. I wasn't marking it artistically, but yes, 0 to 30,000 visually appealing, easy to look at.
easy to break up.
Easy to break up into
5.
5 regions, isn't it? If we go 0 to 30,000, That breaks up into nice 6,000 unit increments, doesn't it?
And it also has the high and low weighted.
Doesn't it? It's not
Because you
jacked
add
all the
to
way
both
up.
sides.
Yes. Yeah, I like it. Are we okay with this? Can we go with that? Go 0 to 30,000? I like it. If you want to go 1,000 to 29,000, would you be okay doing that too?
Sure.
Of course you would. Of course you would. Nothing wrong with that either. But I'm going to go with that. Now, see if you guys are okay with this. I'm going to go 0 to 5999. If that's okay.
Yep.
Because that way, I don't think it matters, because I don't think any of these are actually exactly going to be on our demarcations. I don't think. But in case they are, the question is, where do you then put that school? If I have 6,000 here and down here, that would be a problem, wouldn't it? Because then I wouldn't know where to put 6,000 if it... Go ahead.
I did 0 to 6,000 and 601 to 12,000.
That's fine,
Okay.
that's fine. I think going it this way though, and let's come back to that, if you don't mind, Madeline. So this would then be 6,000 to what, 11,999?
Yeah.
Check my math on this, friends, make sure I'm doing this right. 12,000 to 17,999, yes? 18 up to 23,999, and then 24 up to 30. And it does not matter if you do it this way or if you did it, as Madeline said, go 0 to 6 and then 6,001 to 12, 12,001 to 18. Doesn't matter to me. You're always going to have one extra number left over somewhere. For example, and this is a minor point, it's a mathy point. There are 6,000 numbers in this range between 0 and 5999, because you have to include 0. Exactly, Patrick. There are 6,000 numbers here, 6,000 numbers here, 6,000 numbers here, and 6,001 numbers down here. Because there are 30,001 numbers between 0 and 30,000. Now you can alleviate that by saying every school has to have an enrollment of at least 1, and make that be 1 to 6,000, 6,001 to blah, and then you're covered. Because I don't think a school with 0 students will stay open very long. Make sense? Fair? Now, Nick, your point about bringing this into Excel would be great, because then we could sort it and look. But unfortunately, all we can do now is let's start counting. Let's start counting 6, 4, 1, 4. I'm gonna make a tally list first, and then go back in and change it to numbers. That's okay with you guys?
Yeah.
Does that make sense? 6, 4, 1, 4, 1550, 2109. 9, okay, so we're down here. You guys count them out.
9350.
9350, got that one.
21.
43.
5944.
Wait, 40.
4,300.
40.
Oh, 4,300. Wait, 43,000. That's okay. 4,300. Go ahead.
Did we get 5944?
5944. I don't think we do. Ooh, 5944 is up here, isn't it?
5722.
Okay.
2825. 2044. 5481. 5200.
Nice.
53. 2750. 10,012.
This is fantastic.
6357. 27,000. 9414.
9414.
Yep. 7681. 3200.
Does everybody see what the hell I'm doing? I'm sorry, I'm going pretty quick.
Yeah.
I'm hearing the number Madeline's counting out. Give me the next one, Madeline.
17,500.
17,500. And then I'm just scanning down here and seeing where that number falls. 17,000 falls in here, as long as it's 17,500. Right, 500. Boom. And then I just draw a line there. All I'm doing is I'm dropping in where the number is in the ranges. Go ahead, keep going, my friend.
9,200.
9,200, so I'm scanning. 9,200's in this range. So I drop a line there.
7380.
7380 is going to be in that range as well.
18,314.
18,314 is down here.
6557.
6557 is going to be here, right?
13,713.
That's going to be here.
17,768.
That's going to be here.
7493.
7493 is going to be here.
2771.
2771 is going to be here,
2861.
which is also...
27.
No, I'm sorry.
2771 is not 27,000.
First one.
20, that's over here, isn't it? And is this the 28? Is that what I heard?
Up top
2861.
too.
1263.
Up top.
That's good, thank you.
7285.
7285 is going to be here.
28,165.
Thank you. I got you now, Matt. You're actually saying 28,000 when they're thousands. Thank you. Finally.
5080.
5080 is going to be here.
And 11,622.
11,622 puts us here. And we can leave it like this, actually. It's not a bad indication, but we can also we got to tally them up. So we got 16 across the top here.
35. That's good.
So I either counted right or I counted them so they canceled each other. So either way. So we got 16 here. We've got, what's that, 12?
Yep.
3, 2, and 2, and that's what they wanted us to do. And I think you guys can handle a histogram. You guys can handle the histogram now that you got the distribution, because it's just a matter of making that 2D. But you see what we just did though? Could you have set up those ranges differently?
Yes.
Of course you could have. You could have spread them differently. You could have used the smallest one, which was whatever it was, 1263 as the low end, and you could have used the high one as the high end. High one was what? The 28165, and then you do the 28165 minus 1263. Divide by 5, and that tells you how wide they have to be. I think this makes more sense, right? As soon as you do this, you lose a little bit of exactness, don't you? As soon as you do this, you lose all those individual, you don't really know how close to 0 are these. But that isn't the point, as you'll see today when we actually go back and look at your key data from last class. You do lose something, but it's also negligible. And we'll come back to that. It also goes back to Madeline's question about the width of the bar in the last one. There's something that we're about to kind of uncover together that'll put y'all at ease, I think. It'll answer a lot of the questions that Kat brought up today, and some of you are kind of like, I'm still not quite buying it. So go take 5, you're getting that glazed look. Go take 5, get some air, get some water, want to crack some windows, get some fresh air. Let's come back and talk some more. Yeah.